Hello viewers and welcome to another episode of Space Science with Python. Last time we had a deep dive into the short period comets and especially the ones that have an astro-dynamical link with Jupiter, and we talked about the Tisserand's parameter. Now today I would like to dive a little bit deeper into the Tisserand's parameter. As you may recall, it was a multi-dimensional or multi-parameter function where you have the eccentricity in there, you have the semi-major axis in there, and also the inclination. So it's quite difficult to visualize everything in a single image. So today we will create a small video or an animation to get a better feeling and understanding how the Tisserand parameter solution space changes. And how are we going to do this? Well, we will create a two-dimensional plot. So the Tisserand's parameter will be color-coded. We will plot the eccentricity and the inclination, and we will let the semi-major axis run from, 0 to 8 or 10 AU. So each image will contain, or each frame will contain the solution space for different semi-major axes. And then at the end, we will stack this together into a nice GIF. So the GIF is then something you can present your colleagues or upload on the internet or something as a small animation. And we will see today how we can create these kind of small videos or images or animations with Python. Again, as always, I prepared some code, of course. Now it's already the video number 20, so we are learning a lot. I hope you do so as well. And today's session is also stored on GitHub. And the first cells are a little bit redundant from what we did last time, so a small recap. The very first cell, we import some modules we need today. We will we create here some sample ephemeris time for the year 2000. We compute the state vector of Jupiter. We take the g time m value of the Sun and compute the orbital elements of Jupiter. So at the end, we extract all information that are needed to compute the Tisserand's parameter with respect to Jupiter. So here in line 20 of this cell, you see the Jupiter in AU, semi-major axis in AU. Now, as I said, we want to make some two-dimensional plot. We will visualize the eccentricity versus the inclination, and the Tisserand's parameter will be color-coded for a particular semi-major axis. So we have here the inclination range from 0 to 90 degrees in 100 steps, and here we have the eccentricity from 0 to 1 in 100 steps. And then here, as last time, a lambda function that encodes the Tisserand's parameter. So you see here the semi-major axis of Jupiter, the semi-major axis of our object later, the inclination you see here, and also here is the eccentricity with the power of 2 in some square root function. Now, how can we create a two-dimensional plot? Now, we need to create a mesh grid, or mesh, for matplotlib, and this mesh grid can be created with NumPy mesh grid, where we provide the eccentricity and also the inclination given in radians. Now we can start coding our new content, and it's now especially today a little bit about plotting and creating this animation. Now, first of all, we will need matplotlib, and also let's import also some kind of color mapping, because I want to control it a little bit. As always, as in all other videos before, you already see I want to use the dark background and set the font size a little bit larger from, I think the default is 11 or 12, and I would like to put it to 14. So let me do this here. Font size, font dot size, :14. Yep, this works. And we want to create the color map for different semi-major axes, we will say, okay, we will do this in 0.1 AU steps, and we of course need as well a semi-major axis array ranging from 1.0 to, let's say, 8.0 plus delta A in delta A steps. Yeah, that's quite nice. Now, what do we want to achieve? I would like to create some images. So this maps for each semi-major axis step, and I want to store each individual image in some folder, and later this folder is read and the GIF is being compiled. So first of all, let's maybe create a folder, a directory, and this will be called /temp. mkdir creates the directory, and if it exists, okay. So if you rerun the script, there will be no error spawned. Now, when we create a lot of images, it would be nice to have some kind of progress bar. And for this progress bar, I would like to introduce a new library called TQDM. I added this also in the requirements txt, so you have to rebuild the container. And I was thinking maybe now after 20 videos, some people join a little bit later or so. I will provide some add-on at the end of this video how to recreate a container. So as a small recap, you can skip this, but just take the contents bar here on YouTube to go to the corresponding section to see how to recreate this container. Now I would like to create the figure, and I will create the subplots, the figure size, some default one, 12.8. And now we can iterate through the semi-major axis. So I say something like A4 in. Now you see TQDM, and TQDM is is used by it's like a function that encapsulates everything that is now being executed in the for loop. And you will see what happens. TQDM will spawn a small progress bar in the shell, which is quite nice to see how long it takes to create the images. Now, since we are doing this in the loop, we would like in the very beginning to clear our image. We will also create the X limit from 0 to 1, so the eccentricity, and the inclination. Let's put this from 0 to 90, so this is on the y-axis. And now, of course, we need to compute the Tisserand parameter, but we need a mesh for matplotlib. So we will call the Tisserand jup lambda function. We will use, nope, this is wrong. We will use the semi-major axis array and the index. Yeah, actually, I could have used here enumerate, but yeah, let's stick with this one here. Where was I? Ah, yeah. And then, of course, also the inclination mesh and the E mesh. Yeah. So I think this will work. Let's execute it when we create our images. Now plot.title. In our title, I would like to add the semi-major axis so that we see what's going on. So if you want to pause the video or the animation, we see the current value given in AU, of course. So yeah, let's round it. A array A4. Let's round it by maybe 2 digits. Yeah, we were wondering why I'm rounding it, because it's only in 0.1 steps. Well, sometimes in Python, you know, it's maybe just rounding it to the, I don't know, the 10th digit after the comma or so. So let's just want to prevent some ugly formatting. And of course, let's set also X label, which is the eccentricity, and also the Y label, the inclination in degrees. We have to be careful because the inclination is computed, or we use the radiant values, inclination in degrees. Okay. And now we can create our contour plot. So let's say contour plot equals plot.contour f. And what do we need? We need the eccentricity mesh. We would like to use the numpy.degrees of the inclination value. So we have to be careful here. Up in, come on, inclination red mesh. And then, of course, the Tisserand Jupiter mesh. And then we define the colors. I already checked it a little bit and prepared it. Let's only visualize the interesting part in some colors for Jupiter family comets. So everything that is smaller than 2 gets a unified color, and everything that's larger than 3 gets a unified color. So we set it between Vmin of equals 2 and Vmax equals 3. And then we can also create our individual CMap, and I will use CMR map. And then extend both. So what does the extend both means? As I said, we are defining it between 2 and 3, but we have also values smaller and larger than 3. And our color bar will just show 2 to 3 apparently. But to indicate that we are also having values larger than 3 and smaller than 2, we will draw some arrows in there in the color bar. And you will see this in the moment. So we will also add as well some kind of levels. So let's say we will use numpy linspace, and then from 2 to 3 in 0.1 steps, basically. Yeah, so this will look quite nice, I think. Yeah, I apologize for this popping up here, the Firefox. I don't know what's going on. It's probably on my tablet currently running. Let's do let's add some label also to the color bar. So figure.colorbar contour plot is the color bar, and then we can say callbar dot axis set y label Tisserand parameter. And finally, we can save the figure, and we can say, okay, where do we want to store it? Yeah, apparently in the temp folder. And there we say, okay, let's use the current semi-major axis value, so A4 plus 1. So yeah, maybe something like in steps. And then we can say zfill 3, so we will not have more than 100 images. So we will fill up the first numbers with zeros, so that we will not have 1, 2, 3, 4, 5, and then 10, 11, and so on, because maybe later our algorithm that reads in all the images will get confused and put, for example, the 2.png after 20. So we prevent this by filling up the name with leading zeros. Yeah, leading, not trailing, leading zeros. And we will store this as a PNG, and then we can also set, I don't know, the DPI to, let's put like 100. Now, if I execute this, you will see a small progress bar. You will not see the images. So let's see. And I did a mistake. Now that's bad. No such file or directory. Well, apparently I would like to create it, right? Ah, okay. there's the mistake. The slash has to be here. So let's rerun. And you see it works now. And it creates now our images, in total 71 images. We have a new folder called temp, and there you see the images are being filled up with the trailing, with the leading 0. So yeah, Z fill of 2 would be enough, but yeah, let's fill it up here. And let's wait for a few seconds. And this is what you see with TQDM. It's quite nice and clean progress bar. It also estimates how many seconds are left. And here we see now the last image, the eccentricity on the x-axis, the inclination in degrees on the y-axis, and the semi-major axis given in 8 AU, so the semi-major axis of the object. And here's the Tisserand parameter, everything with respect to Jupiter. And you see now a nice, neat contour plot. So we have now different solutions, computed different solutions between 2 and 8 AU. And now it's up to us to stick all these images together to create an animation. And how do we do that? Now, first of all, we will use a library called imageio. But before we do this, imageio expects us to give us a file name. But let's think a little bit about the order of the file names, how we would like to create our animation. Now, let's say I will first import glob to get all file names. So file names is glob.glob. I like the name. Temp / png. So I will get all file names. Let's verify this. Yeah, it exceeds the limits. Okay, a little bit large for the text editor. You see here all the file names. I don't know if this is necessary. I don't know what's going on your computer. So let's sort the list maybe, just to be sure that it will work on every machine. And now we have our images from 1 to 71, so from 2 AU to 8 AU. And what would I like to do is, well, let's take the name list and let's extend our list. And we will use the same list again up to the only the very last image. And we will multiply it with 22. So thinking a little bit that the animation will start from 2 to 8 AU. Yeah, so in, I don't know, 24 frames per second, it goes up. Then we wait for a few seconds, or for a single second, or 2 seconds if you have 12 FPS. So for a second, so that we can see the image a little bit still without no movement all the time. And then afterwards it goes back. So it will move back from 8 AU to 2 AU. So we have to take the very last image for 25 seconds, 25 frames. Now we have to invert the list, extend our list again, and then we will add 25 frames for the very first image, so that we can create a nice loop with a short break at the very end and a short break at the very beginning. So I think this will be a nice, neat animation. So we take again our data frame, and then we say extend file names. And how do we invert a list in Python? It's : :-1. So it goes now back in, not in time, but back from 8 AU to 2 AU. And then we extend it with 25 images. Again with 25 images. I'm a little bit confused. Where is, oh yeah, there it is. Okay. All right. Yeah, again, I will add a lot of comments so that you will see how things work. Now let's see, no error spawned, perfect. Now we can import imageio, and we say the Tisserand images empty list, and then we say figure F in file names list, Tisserand's images dot append. So we put the images now here in this Python list. So we say imageio dot image read figure F. I could have used the list comprehension writing this code, but yeah, it's fine. And then we say imageio image mim save, and let's call it Tisserand animated visualization.gif with the Tisserand images, and then we can say the duration of each image 0.04 seconds. So it's 25 frames per second. Yeah. Okay, so we can, I could have used also, I cannot use TQDM because this writing will take some time, maybe like 10 or 20 seconds. So let's wait. In the meantime, I can switch to my other screen. Yeah, GitHub is running in the background. Yeah, it's not gig, it's GIF. Okay, let's see. This should, the GIF is created. Now a few more minutes or seconds. Now this is quite slow today a little bit. I don't know, maybe my computer is doing some updates in the background. Launchpad probably via Xcode or something. Now we have this GIF here, and let's open it maybe with Safari. And there you go. Yeah, and you see the animation, perfect. Going from 1 AU, not 2 AU, from 1 AU to 8, short break. And then it goes back to 1 AU, pretty bright. And then you see if maybe a better understanding or feeling how the Tisserand parameter behaves. And this should be the summary and short conclusion of today's session. This animation has no huge value or something. It's more about giving you an idea how the Tisserand's parameter may change. We will also create some kind of interactive tool with Plotly in the future, where we will click around and adjust the parameters to see how the solution space behaves, which is more interactive than this hypnotic animation. But I hope you learned a little bit, especially how to create this kind of animations, how to, maybe you have never heard about TQDM, which is also maybe quite new to you. And we will continue with another comet topic also in the future, but I think this should be now for it with the database and so on. We created some nice content, quite nice data insights. And until next time, I wish you a very nice day as always. I think uploading this video, it will be also already 2022. So happy new year as well. And I wish you happy coding and see you next time. Okay, I'm back. This is a small add-on as promised to show you how to rebuild our remote container in VS Code. So again, Docker is running in the background and it requires an update. I should do this. And I have VS Code running. I opened the folder with the tutorials, but you see there is no shell or whatsoever, and the Python Jupyter Notebook cannot be shown. Everything is pulled from the Git repository, so the most recent version. I pressed Shift Command P, so the option the key, the button right next to the option button on the Mac keyboard. On Windows, it should be 2 buttons right from the control button on the left side. And then you see here the command line, and we can here open the folder and container. So this would open our current version. But since we have some updates, we updated the requirements txt and so on, maybe also the dev container JSON. It's time to rebuild and reopen the container. So you click here, and yeah, if you're already in the folder, in the project folder, it will immediately start. So the container is building. But if you are in a different folder, it will also show a prompt asking you which folder you would like to create or build up. I don't know if I will make a small break now. Yeah, Pylance and so on is installed in the background, so these warnings can be ignored. Everything is in the dev container JSON. So let's wait for a few seconds. Yeah, you see here the extension was successfully installed. So yeah, VS Code is sometimes complaining about stuff, although it's not yet finished with creating the container. So yeah, just wait until the container is built completely.